All right, kiddos, last set of questions. We should be ready for question number 16. Question number 16 says, solve for x. All right, the first thing I see is a triangle. If I look more closely, I'm given more information than it's just a triangle. I am given this shape in the corner, which is very special. It tells me that this is a special type of triangle. As a matter of fact, it tells me that it is a right triangle because that symbol in the corner tells me that this angle from here to here is a 90-degree angle. I am trying to figure out what the measure of angle X is. And here's what I know. I know that this angle is 90 degrees. I don't know what this angle is from here to here, but I know that it is 4 times smaller than this angle from here to here. That's why this angle up in the top corner says 4x. That means it is 4 times larger than whatever this angle is down here. I could probably guess and check, but in order for me to even start knowing this problem, what I have to be aware of is that triangles, the angles inside the triangles, let me actually make that bigger. All of the angles inside of a triangle always, I don't care what kind of a triangle it is, they always add up to give me this. Do you know? If I take those 3 angles, and let me actually call them something different than dots. Let's call them angle A, angle B, and angle C. If I add those 3 angles together, I should always get 180 degrees. That is part of the definition of a triangle. So I'm going to use that information to help me solve this problem. I'm going to again go back into this picture and add in a little more information. I know that this angle down here is 90 degrees. And I know that if I add these 3 angles together, I will get a total of 180 degrees, which is always the sum of the interior angles of a triangle. So I'm going to go ahead and write it as 90 plus 4x plus x. I know if I add those 3 together, I'm going to get 180 degrees. It doesn't matter the order that you add them, addition is commutative. All right, so hopefully that part wasn't too complicated for you to understand. This is where things might get a little bit more confusing. We now need to solve this equation. And for those of you who were either not with me at that part of the year or who never really understood how to solve equations, please take very good notes right here so that you can be successful on the actual test. Okay, step 1 is going to be to combine your variables together. Okay, so in this sentence, 90 plus 4x plus x equals 180. I see 4x plus x. Those are my variables. I want to combine them together. So if I have 4 x's and I have another x, the invisible number sitting in front of it is the number 1. If I combine that together, 4 x's plus 1 more x, I get 5x. So I'm going to be left with 90 plus 5x equals 180. All right, so I've done step 1. I've combined those variables together. I'm going to move on to step number 2 in solving an equation. Step number 2, I want to leave that variable alone. I'm not going to touch this 5x. I'm going to get rid of the other number. And in this case, the other number on the same side as the 5x is the 90. So I'm going to get rid of 90. If that number were 12, if that number were 180, I would get rid of it. Okay, and how do I get rid of 90? I'm going to subtract it. I'm going to give it away. So I'm going to subtract 90, and whatever I do to one side, I'm going to do to the other side. Okay, so I'm going to now look here. 90 minus 90 is nothing. It eliminates, and I'm left with 5x on the left side. And 180 minus 90, I just know off the top of my head is 90. If you needed to use a calculator to subtract that, you could. All right, guys, because I'm running out of real estate, I don't have room. I'm going to just rewrite this up here. 5x equals 90. This is telling me 5 times something gives me 90. 5 times something is 90. So in order for me to figure that out, I'm going to do 90 divided by 5. All right, how I taught that and how you've seen that written when you're solving equations looks like this. I'm going to do divide both sides by 5. So I'm going to do 90 divided by 5, which is 18. All right, if you want me to prove it, I would do 90 divided by 5. 5 goes into 9 one time. With 4 left over, bring down the 0. 5 goes into 48 times. 5 times 4, sorry, 8 times 5 is 40. So you can see that it went in 18 times. The question asks me to solve for x. X in this case is 18. The correct answer is B. I probably should have also stated that step 3, because we got rid of the 90 and we were left with 5x equals 90. The last step, step 3, is to divide by the coefficient. That would be the number 5. Okay, so in this last step, this would be step 3. I divided by the 5, which we call the coefficient. If this equation happened to say 12x equals 180, I would have divided by 12. I would have divided by whatever that number is in front of the variable. This is a great time to take notes. I do not suggest you just watch this and move on. In order for you to get this correct on the actual test, you have to know how to solve an equation. So make sure you copy down those steps. Pause the video if you need to. Moving on to question number 17. Question 17 asks, what is the volume of this triangular prism? In order for me to answer this question, I need to know how to find the volume of a triangular prism. If I don't know the formula, I am going to look it up. The good news is that it is on your slideshow. I'm going to jump back over to the slideshow, and I'm going to find the formulas for volume. And it looks like they're on slide number 19. All right, I believe we were looking at a triangular prism. And here is the formula for the volume. SA stands for surface area. Remember, surface area is like if I had this shape as a gift and I wanted to wrap it with wrapping paper, how much wrapping paper would I need? That's surface area. Volume would be if I wanted to take this shape and fill it up with water, how much water would I need? That's volume, right? So this particular slide shows you not only the formulas for the surface area, but also the formulas for the volume. Make sure you're using the right one. Ladies and gents, you're not going to see me copy down any formula for this because I think there's an easier way. I'm always about not having to memorize if I don't have to. So I'm going to do it my way. I'm going to show you what that is. To find the volume of any shape, I don't care what shape it is, here are your steps. Step 1 is to find the area of the base. Whatever shape you are asked to find the volume of, step 1 is to find the area of the base. Step 2 is then to take that area, that answer, and multiply it by the height. Every single shape, every single time we're finding volume. All right, so I can forget having to go and retrieve a formula if I understand how to find the volume of something. And in this case, what I really need to be able to do in this particular picture, which again is a triangular prism, is to understand what the base shape is. So the bases are always identified in a 3D object by the two shapes that are identical. All right, now I know this is only two-dimensional, but you could picture this as a three-dimensional figure, and the two shapes that would be identical are the two triangles. The other three sides would be rectangles. Let me see if I can show you that in a better way. This may or may not help depending on how good you are visually with objects. All right, so here is another angle or another view of a triangular prism. And what I'm telling you is that we could number these sides. All right, so this would be the side right here might be the one that's facing me, closest to me. And I would call that side number 1. And then the side on the bottom here that it's sitting on would be side number 2. And then the side facing away from me, which is kind of hard to visualize, but that would be the side facing away would be side number 3. Those are all called the sides of the prism. The bases are different than that. The bases are the two shapes that are identical, not the 3 shapes that are identical. Okay, so in a prism, these two shapes are identical. Therefore, we call these our bases. And the base shape of a triangular prism is a triangle. That's why they name it that way. They name it by the shape of your base. Okay, so if I knew nothing else and I saw that it said a triangular prism, I would know that one of these triangles is my base. And why is that important again? Because in order for me to find the volume, I'm going to find the area of the base, and then I'm going to multiply it by the height. Okay, so I'm going to use my crazy picture over here. It's telling me that the dimensions of my triangle, the dimensions of this triangle are what? What two numbers go with this triangle? Well, hopefully you can pretty easily see them, 6 and 8. All right. So in order for me to find the area of that base, I need to know what the formula is to find the area of a triangle. I know that. If you don't know that, you're going to have to go back to the slideshow and look up how to find the area of a triangle. The formula for an area of a triangle is base times height divided by 2. Some of you might have been taught that as 1/2 your base times your height. My experience as a math teacher is that anytime a kid sees a fraction, they freak out and run away. So I try not to use that. They mean the same thing, so don't worry about it. All right, I'm going to use base times height divided by 2. And I'm going to use those numbers that I've been given of 6 and 8. Those go along with the triangle. So to find the area of the triangle, I'm going to use, I don't know, let's say 6 for the base times 8 for the height, and divide it by 2. Doesn't matter if I switch those two numbers. Multiplication is commutative. I get the same answer. So I'm now going to do 6 times 8, which is 48. And 48 divided by 2 is 24. So ladies and gents, what I've just discovered is that the area of this base shape is 24 cubic feet. All right, why cubic? Because we're dealing in 3 dimensions. So this is 24 feet cubed or cubic feet. And again, we use that 3 because we have a 3-dimensional figure. All right, now step 2 is to take that number 24 and to do what with it? Well, our directions say to multiply it by the height. And the only number we have not used in this figure that would be the height of it is 14. So my last step then is to take the area of the base, which was 24, and to multiply it by the height, which is 14. I'm going to go ahead and use my calculator for that. 24 times 14 is 336. Okay, so the volume of this triangular prism is 336 cubic feet or feet cubed, which is this choice here. One of the most common mistakes that kids make when working with volume is memorizing one formula and using it for every different shape. Most kids want to take length times width times height, and they just want to do 6 times 8 times 14. I guarantee you that answer appears. I'm going to check 6 times 8 times 14, and that answer is 672. That answer will always appear because it is the formula that most kids use when working with volume, even when it's not the right shape. Please take down your notes. Pause the video if you need to. Question number 18. Oh, take a look at that picture. It says, Sarah is laying sod in her yard that is oddly shaped. There is a 6-foot by 6-foot pond in the backyard. What is the total area that Sarah needs to lay sod on? We are being asked to find the total area. All right, and in order for us to find that area, we have a couple of choices to make. We are going to have to look at this picture, and we're going to have to decide how we want to approach it. Every person's brain works differently. I'm going to show you a couple of options, and then I'm going to pick one and do it. The first option is to take this shape and to cut it into 2 different rectangles. Okay, one of the rectangles might be a very long and tall rectangular shape, and then a squatter, little bit less long rectangular shape. We could find the area of those 2 shapes, and then we could figure out the area of the pool, and we could figure out what to do with that. That's one option. Maybe you looked at this picture and instead you decided to cut it this way, horizontally. And you said, okay, well, let me find the area of this long rectangular piece sideways, and then find the area of this shorter kind of square looking thing. And then we could find the area of the pool in here and figure out what to do with it. A third option would be to say, well, dang it, I'm going to just create an entire full rectangle. I'm going to find the area of this entire rectangle, including that white space. And then maybe you'd find the area of this part of it and subtract it. And then maybe you find the area of the pool and subtract it. Right? You can approach this in several different ways. There is not one way that is better or more efficient than the other. So what I'm going to do is I'm going to pick the way that represents the way my brain sees it, and I'm going to show it to you that way. Right? You could certainly do it in a different order, but the goal is that you get the same answer that I do. If you choose to cut your shape into different pieces and you don't get the same answer that I do, you want to make sure you ask me before you take your test. All right, guys, so who's in my camp? Who sees this shape as this long rectangular piece? I'm going to number that number 1. This shorter kind of squatter, more narrow rectangular piece as number 2, and then the pool is number 3. That's how my brain would cut it. You're totally welcome to do it your way. No matter which way you cut the figure, the hard part is knowing which numbers go with the different lengths and which widths of each rectangle. So that's what we want to be really careful about. So here we go. This is a very difficult critical thinking question. I'm going to find the area of shape number 1, right? That's numbered here. And I am going to remember that it is a rectangle. So I'm going to be using the formula of length times width. Here's a note, a good piece of information. The shape on the actual test is the exact same shape as you are seeing right here. I've just changed the numbers for the practice test. So as long as you follow along, writing down all the formulas and the steps that I'm using, you're going to be able to get the actual test question correct. Okay, so we are going to find the area of this great big rectangle first. And what I need to know is how long it is and how wide it is. The length of this big green rectangle is placed on the outside of the shape. From here to here is the length of that rectangle. So the length of this rectangle is 22. And the width of this rectangle would be from here to here, or from here to here. They're the same. That's what makes it a rectangle. The only side, top or bottom, that gives me that dimension is the bottom, and it tells me that it is 8 feet. So the width of that rectangle is 8. Okay, so I'm going to find the area of that rectangle. I'm going to do 22 times 8. I'm going to use my calculator to support. And for that rectangle, I get that the area is 176, and that's a rectangle number 1. Okay, I'm going to erase some of this stuff that's not important anymore. Okay, and now we're going to focus on rectangle number 2. So step number 2, I've already done finding the area of rectangle number 1. Now I'm going to find the area of rectangle number 2. All right, and remember it is a rectangle, so I'm going to do length times width. And I have to figure out what the length representation is and what the width dimension is. So I am looking now at this rectangle right here, and I need to figure out which one's the length and which one's the width. So again, my length is going to go either from here to here or here to here. And the only one that actually gives me that unit of measure or that dimension is this 10, which goes from here to here. And then the other one would either be from here to here, or from here to here would be the other side. And that one is 14. Okay, now remember in rectangles, the longer dimension is always your length and the shorter dimension is your width. So in this problem, I'm going to call 14 my length and 10 my width. I could have switched those around. That's not a problem. So what I'm going to do to get the area is I'm going to do 14 times 10, and I know that that gives me 140. So the area of that second rectangle is 140. All right, the third thing I need to do is to find out what the area of the pool is, because I'm not going to put sod on that. All right, so I'm going to come over here to the bottom because that's where I have some room. And now I'm going to find the area of shape number 3. Okay, now in this case, I would normally call this length times width, but watch what we're going to bump into. In this third shape right here, our length and our width are the same. That's why they're telling us that, and in this case, it says 6 foot by 6 foot, but my numbers say 4 feet by 4 feet. Oh no, which one do I use? I'm gonna have to guess. That's my mistake. That's a mistype on the question, the practice test question. That's my bad. I apologize. So I'm gonna try and use, I'm gonna use the 4 by 4 and assume that I rewrote this incorrectly up here. This will not happen to you on the actual test. This is an apology by me. Let's call this 4 by 4. Okay, so if I'm going to find the area of it, the length and the width are, one's supposed to be longer than the other and they're not. So it doesn't matter the order that I put them here. I'm just going to call it a 4 by 4. And so I'm going to go area of the pool is 4 by 4, which is 16. 4 times 4 is 16. And now I need to figure out what to do with these 3 numbers. Remember, my 3 final numbers that I found are 176 for shape 1, 140 for shape 2, and 16 for shape 3. Remember, the goal is to cover these items with sod. And so I am going to add the shape 1 and the shape 2 together to give me my total area. But when it comes to the pool, I am going to subtract the pool's area out because I don't want to cover it with sod. And when I found the area of this shape right here, it included the pool. So I need to remove that area from it. So watch how I do this. I'm going to now go and do 176 plus 140. Which gives me 316. And then from that, I'm going to subtract the area of the pool, which was 16, and I end up with 300. And that is the correct answer for the quiz question. So I guessed right. So that means that the written portion of this test question was incorrect. It should have said 4 feet by 4 feet, but the picture portion of the practice test is correct, where it gave me my dimensions inside that rectangle of 4 feet by 4 feet. Correct answer is 300 square feet. Now remember, if you did this one a different way and you cut those shapes in different pieces, it is okay as long as your final area turned out to be 300. If you got some different answer, make sure you ask me about it before you take the actual test. Moving on to question number 19, we have 2 to go. Okay, this question number 19 asks me to find the surface area of a rectangular prism that has sides that are 4.5 feet and 6 feet, and it has a height of 2 feet. Surface area is one of the hardest things to calculate. I'm going to start by drawing you a picture. It is saying that I have a rectangular prism. So the way that I'm going to draw this is going to try and represent a rectangular prism. So both of my base shapes should be about the same. And then I'm going to connect them with lines. All right, so let's just pretend that this is our rectangular prism. And I am trying to find the surface area, which means that I'm trying to figure out how much wrapping paper I would need to wrap this rectangular shape. And this is what I know. I know that the base, and remember the base is the 2 shapes that are identical, not the 4 sides that are identical, but the 2 shapes that are identical. Those are my bases. All right, it tells me that the dimensions of my bases are 4.5 by 6. That's what it says right here. And then it tells me that the height of this prism is 2 feet. That means from here to here, how high it is 2. Okay, this picture is obviously not drawn the same way as the dimensions give you, but you get the idea. All right, guys, so here are 2 different ways that you could go about this. You can go about this the logical way, or you can go about this the formula way. The logical way is to find the area of all 6 sides of a rectangular prism. I could find the area of each of the 2 bases by doing length times width. I could find the area of all of the side shapes. Those would be in yellow. I could then also find the area of the 2 top shapes. There should be 6 sides on any prism. And if I find the areas of all 6 of those shapes, I could add them all together and get the surface area. That's all surface area means, okay? However, that takes a lot of math, and there are a lot of opportunities for me to make mistakes. So, believe it or not, when I go to do surface area, I pull a formula, right? You'll very rarely hear me say that, but when I'm doing surface area, that's what I do. So here is the surface area formula for a rectangular prism, and that is the exact same shape that you're going to see on the test. So if you pull the formula from me now, then you will be able to use the same formula on the test and just change out the numbers. So here's the formula for surface area of a rectangular prism. You take 2 and multiply it by the length times the width, which is added to the width times the height, which is added to the length times the height. All right, it sounds pretty complicated, but watch how I do this. The first thing I'm going to do is I am going to identify what each letter means. All right, so the length, the width, and the height. And here's the easy part. I know the height because it gives it to me. It tells me that the height is 2 feet, so I know my h is 2. That means this is the height. And here's the good news. It doesn't matter which one's the length or the width, just so long as I call one length and I call one width. And if you've been listening to me through this video, you'll know that the length is always the longer side. So I'm going to call my length 6, and I'm going to call my width 4.5. All right, so my width is 4.5, my length is 6, my height is 2. And now, guys, all it is a substitution. I'm going to take these numbers, and wherever I see those letters, I'm going to substitute them into that formula. So this is how it goes. I'm going to do my surface area is equal to 2 times my length times my width. My length is 6, my width is 4.5, plus my width times my height. My width is 4.5. My height is 2. Maybe I'll use the times sign in here. Might make it a little easier. There's too many dots. And then my length times my height. My length is 6. My height is 2. Okay, so I'm going to do what's inside the parentheses first. So I'm going to do these multiplications. First thing I'm going to do is 6 times 4.5. And again, using my calculator. And I get 27. And then I'm going to go ahead and use my calculator to do 4.5 times 2. And I happen to know that's 9. I could use my calculator. And then I'm going to do 6 times 2, which is 12. Right? All I did was I multiplied everything inside that grouping symbol. Now I'm going to add everything inside the grouping symbol together first. So I'm going to do 27 plus 9 plus 12. And I get 49. And then the last step, did I do that right? Oh, I did not. It's 48, not 49. Glad I caught that. That would have been bad. So adding 27 plus 9 plus 12, I get 48. And then the last step is to multiply it by 2, and 2 times 48 is 96. And again, I could use my calculator or do the math. So the surface area, the amount of wrapping paper that I would need is 96 feet squared or square feet because we're finding an area. It's 2-dimensional, therefore we're using squared. 96 is correct. Now, here's what I just want to tell you guys. If you accidentally didn't read this question carefully, and let's say instead you found volume, and remember I told you the most common formula for volume is length times width times height, and you just multiplied those 3 numbers together, I guarantee you that that answer appeared 12 times 4.5 is 54, and it will appear. So you have to read your questions carefully, and luckily you've got this practice test that's guiding you through. Okay, so copy down all of these notes. The only thing that's going to change on the actual test are going to be these numbers in here. All right, you're going to have different lengths, widths, and heights. So these are the only things that are going to change from this line down. The math is going to be a little different, but the formula will be the same. Pause the video, take down what notes you need. All right, guys, last question. Last question says, what is the volume of the figure shown below? Volume, how much water could we fill it with? And what I see when I look at this picture, I see two shapes. And I see two rectangular prisms, basically Kleenex boxes. Maybe I see a square Kleenex box here in the front. It's 5 by 5 by 4. It's not really a square. It's not a cube, or all three of these dimensions would have been the same. But I see that rectangular prism in the front, and then I see the big rectangular prism in the back. What I'm going to do is I'm just going to find the volumes of those two shapes separately, and then I'm going to add those volumes together. Okay, so how's that going to look? Well, I'm going to number my shapes to keep them organized. I'm going to call this shape number 1, the one in front, and I'm going to call this shape number 2. And when we are finding the volume, remember I told you I don't memorize formulas if I don't need to. To find the volume, we're going to find the area of the base, and then we're going to multiply that by the height. In this case, it's more work than is necessary because these are both rectangular prisms, and so we could just do length times width. That's how we would find the area of the base anyway, right? Our base shape would be a rectangle anyway, and to find the area of a rectangle, it's length times width times height. All right, so what I'm going to do here, whether you know it or not, is I'm actually going to use the formula for finding the volume of a rectangular prism with it, which is length times width times height. It's just coincidence. Okay, so here we go, guys. Shape number 1, that's what I'm finding. I'm finding the volume of shape number 1, which is that little rectangular prism in the front. And I'm going to use these 3 units of measure, 4 times 5 times 5. Doesn't matter the order that I do that. All right, length, width times height is going to be 4 times 5 times 5. And that is going to give me 4 times 5 is 20, and 20 times 5 is 100. So my volume of shape number 1 is 100. Again, of course, use calculators if you need it. Now I'm going to move on to the shape in the back, and I need to make sure I'm using the right dimensions for that shape. So this 4 inches goes from here to here, which is on the front. This 5 inches goes from here to here, which is on the front. And this 5 inches goes from here to here, which is on the front. So I don't need to use any of those measurements. So the measurements that are, oops, I didn't want to do that. Measurements that are left over are then going to be the other 3 numbers that you see. Okay, so I'm going to be using for the second rectangular prism, the 4, which goes from here to here, by the 10, which is the height, by the 14, which is the length. All right, so to find the volume of the shape in the back, I'm going to do 4 times 14 times 10. I can do it in any order. And I know that 14 times 10 is 140. And then I can multiply that by 4. And I get 560. So the volume of the rectangular prism in the back is 560. The volume of the rectangular prism in the front is 100. Excuse me, the total volume is going to be those 2 numbers added together. 100 plus 560 gives me 660. And again, it's a 3-dimensional figure, so it's cubic inches or inches cubed. Final answer. I hope you've taken good notes. At any point that you want to go back and rewatch these videos or use them while you are taking the actual test, please feel free to do that. I wish you the best of luck. and can't wait to see what you guys can do. If you have any questions, as always, come see me in Zoom or message me in It's Learning.